Welcome to the Keller ITS online service. In this video, we introduce our emissivity calculator and show you how to use it. This will help you for setting up your pyrometer or for selecting the most suitable instruments for your application. The emissivity calculator provides the calculation of the emissivity to be set or provides the information of temperature changes due to emissivity changes. The tool is available at the Keller ITS homepage or also in the Keller ITS app. The emissivity calculator is a great tool during commissioning because correct measurements need the correct emissivity to be set. By using this calculator, you will get the correct emissivity to set for the pyrometer's measuring task. For calculating this, you always need a reference temperature, which can be provided by a thermocouple, a reference pyrometer, or any means of the process. But why should you even set the emissivity? Well, let's make an example. A black bottle and an aluminium bottle are filled with hot boiled water. After a while, the surface temperature of both bottles have the same temperature of 100 degrees, like the boiled water which was filled in. If you now detect the temperature with a pyrometer and the set emissivity for both bottles is 100%, you will note that the temperature of the aluminium bottle is much lower than the black one. This is because the aluminium bottle has a lower emissivity. However, with a correct emissivity for the aluminium bottle, you are able to measure the real temperature of 100 degrees for this material too. This sounds easy, doesn't it? But let's define what emissivity is. Emissivity is defined as the ratio of the infrared energy radiated from a material surface to that energy radiated from a perfect transmitter, also known as a blackbody. The value is between 0 and 1. Please note, the emissivity to be set is always depending on the following three important criterions. First, the material. Second, the surface. Third, the temperature. The emissivity calculator can assist you in three situations. Option 1. During installation or maintenance, you can find the correct emissivity value for a precise temperature measurement. Option 2. In case of possible changes of the material or accessories, you can evaluate the impact on the measuring value. Or last but not least, if you hesitate between two pyrometer models, you can check if one of those has a better accuracy or is less bothered by emissivity changes. Let us now check what you have to do to calculate the correct emissivity. At first, just enter the correct instrument and his type. Then set the current emissivity setting of the pyrometer and also the measured value, and at least type in the real object temperature of the reference. As a result, you will now get the information which emissivity has to be set for a correct temperature reading. The second possibility to use the calculator is to determine the influence to the measuring values if the emissivity varies. For calculating this, easily select the pyrometer model and set the emissivity of it. As a next step, you can set some possible new emissivity, which means the variation. And last, also set the true object temperature from your reference measurement. The differences between the results and the real object temperature, in order to the emissivity variation, will give you a feeling for the temperature readings of your pyrometer if the emissivity changes. The third possibility is a comparison of instruments and deciding which of them is less sensitive to emissivity variations of the surface. For doing this, type in the emissivity which is set and also the correct emissivity of the surface, as well as the real object temperature. The result will show you the measured values of each pyrometer and thus the measurement deviation from the true temperature. In this example, it clearly shows that for the chosen condition, a PA20 is less influenced than a PA29. Perfect! Now you are able and prepared to use the emissivity calculator as a supportive tool for the tasks of calculating the correct emissivity, determining the influence for emissivity changes, and defining the instrument with the smallest influence to emissivity variations. Thank you very much for watching this online tutorial and have a great success. If you have any questions, please don't hesitate to contact us. Your Keller ITS Salesforce.